Today's lesson in 4.3 is about a third method for solving systems of equations. Before we actually get into it, let's talk about the three methods that we have. Two of them we've studied. The first method for solving a system is graphing. And we saw that method in section 4.1. We tended to use y equals mx plus b a whole lot, but it wasn't a requirement. We could have used t-charts. Okay? The second method we did was substitution. That was in lesson 4.2, and we needed the equations to be in the form x equals or y equals so that we could then substitute. Today, we're going to look at our third method, and by the way, there are more methods that are taught in other math classes, and the graphing calculator can do this process as well. But we learn exactly three methods. The last method is called addition. It is in lesson 4.3, and to use the addition technique, you need opposites in x's or y's. I will kind of clarify that in just a minute. All right, I want to give you a couple of examples of what a system looks like when it's ready for addition. In other words, what am I talking about when I talk about you need opposites? Okay, this will be ready for addition. If you have 2x plus 3y is 7, make that go up just a little bit more, and 5x minus 3y is equal to, say, -2. Now, take a look. You notice that the structure of this system has your x's lined up, your y's lined up, your equal signs lined up, and your constants lined up. Do you see a pair of opposites with the coefficients of either x or y? Yes, and I hope everybody sees them right there. That means it's ready for addition. Now, I'm not going to teach you addition for about 30 or 40 more seconds, but it is ready. If we look at one more, I'm just talking about the readiness. If I have x plus 2y is 9, and negative x minus 4y is 7, does that system, based on what I've said, look ready for addition? Yes. Yes, because you've got opposites with the x's. And when you have opposites, that means that the coefficients are the same numerical value, but one of them is positive and one of them is negative. So, is everybody okay with what the format has to be? We remember, I hope, the format for graphing. We got almost everything in y equals mx plus b. For substitution, we had to have either an x equals or a y equals. But for addition, we're going to want things lined up, x's, y's, equal signs, constants, and we're going to want either the y's or the x's to be a pair of opposites. Our first few problems, they are. And then we'll talk about, then what do you do if they're not? Okay, so let's move on. Problem number 1. Problem number 1 says, and I will rewrite the system so that those of you at the back of the room can see it. It says, solve the system of equations by the addition method. And it gives it to you, and you're going to answer with an ordered pair, or with n or I, like we did yesterday. All right, this system, if I recopy it, is negative 5x minus y is equal to negative 13, and negative 4x plus y is equal to 4. All right, the method I have to use is addition. Is this system ready? And you need to ask yourself that question each time, is it ready? And if it is, then identify at least for yourself which of the groups have opposites. And does everybody agree it's the y's? Okay, so you just notice that. Now, the name of this method is addition. Well, that tells you what to do. You're going to add the two equations together. And you want to make sure that like terms have been lined up, and they are. What is negative 5x plus negative 4x? Negative 9x. What happens when you add negative y to positive y? They cancel out, and I don't need to write plus 0. Equal sign. What is negative 13 and positive 4? It is negative 9, because I subtract and keep the sign of the big one. Now, you should get an equation that only has one variable in it, which means you know how to solve it from chapter 2. So what will I do to solve for x? Divide by negative 9, and I will get x is 1. I am halfway to the solution of the problem. When the addition method is, when you're ready for it, you get to the first part of the answer very, very quickly. Is everybody okay with that? Mm-hmm. Okay. The next thing we need to do is what we had to do with substitution, which is now find y. But there is one thing that's different than there was with substitution. With substitution, when I backed up and I looked at my system, I had a circled equation, and it was just screaming, pick me, I'll make your work easy. There's no screaming going on here. You have equation number 1 or equation number 2 to pick from. And it doesn't matter which one you pick to find y. It just doesn't matter. So which one would you like me to pick? The second one. The first thing I heard was the second one. Now, the reason I would have agreed with the second one is that the y is positive. And I kind of like positives. But the truth is it doesn't matter, and I think we have time. I'll do it in both of them and show you. All right, so if I pick negative 4x plus y is equal to 4, and you might write yourself a little note, it doesn't matter which one I pick. I'm going to take x as 1, and I'm going to plug it in. That gives me negative 4 times 1 plus y is 4. Negative 4 times 1 is negative 4 plus y is 4. And what do I do to finish solving that for y? Okay, I'm going to add a 4 because that's a negative 4. So I'm going to add 4 to both sides. That's gone. And I have y is positive 8. Now, I'm going to write or, meaning you don't have to do both of these. But if you chose the other equation, which let me see which one that one was. It was negative 5x minus y is negative 13. So if some of you were voting for this one, whoops, and I plug in here, I have negative 5 times 1 minus y is negative 13. Negative 5 times 1 is negative 5 minus y is negative 13. What am I going to do to solve? Add 5, add 5. I have negative y is negative 8, but that's not finished. Divide by negative 1, and y is 8. Did I get exactly the same answer? Yes. Yes, sir.
Can I ask a question here?
Sure.
Maybe jumping ahead a little bit. Are we learning these different methods for future or mathematical endeavors to choose the most efficient method to?
Yes, exactly. Okay, the question was, we're learning these different methods. Is it so that in the future, maybe in an application problem, we decide which of the methods would be most efficient for that kind of system? And the answer is yes, and we will actually do that before you leave this room today. Oh, well, are y'all happy or what? That was a collective groan. Okay, our answer for this system, we got 1 for x and we got 8 for y, even though we did that second part twice. Please don't go to all the effort to do the problem twice. You just pick the equation you want. All right, so that is number 1. Let's look at number 2. Number 2 says, solve the system of equations by the addition method, and I will rewrite it so that you can see it clearly. It is 3x plus y is negative 7, and negative 3x minus 2y is 11. The first question, because you're required to do this by the addition method, is it ready? And which variables? I believe the x's are the ones that are opposites.
So why wouldn't the y be? Because
Okay, great question. Why am I not saying anything about the y's? The y's do have opposite signs, but the coefficients are not opposites because one of them is a positive 1 and the other one is a negative 2. And I need the numbers to be the same. Not just the signs to be opposite, but the numbers to be the same with opposite signs. And that's why the positive 3 and negative 3 on the x's qualify. So these are opposite numbers. These are opposite signs, but they're not opposite numbers because I don't have a 2 there.
okay.
Your goal is that when you add them, they cancel out. So if they don't cancel out, they weren't opposites. All right.
The number has to be the same, but the one has to be a positive number with an x, and then the bottom one has to be a negative same number with a y. I mean an x.
Yes,
Okay.
whichever letter it is.
Constant variables have to be
Yes.
the same with a negative and a positive.
Yes.
Okay.
Okay? So the x's are opposites. It's ready. That means that you do what the name of the technique says, which is add. What is positive 3x and negative 3x? 0 cancels. That's what you wanted to happen. That has to happen. Now, it's not going to cancel over here because this is an implied 1y minus 2y. What is 1y minus 2y? It is negative y, and negative 1y is what it is. Equal sign. What do you get when you have negative 7 and positive 11? You get positive 4 because the bigger of the two numbers was the positive 11. But this isn't done. I need to divide by negative 1, so y is negative 4. The first step, the first stage of the addition method can be very, very fast. And then you have to go on and now find the other variable, which in this problem is x. Which of the two equations, because it's a choice, which of the two would you like me to use? Okay, first, second, doesn't matter. I tend to pick equations that have smaller numbers and more positives, but it doesn't matter. So I choose to use, and I just pushed it out of my sight, I choose 3x plus y is equal to negative 7. And I'm going to take negative 4 and put it in the place of y. So I have 3x minus 4 is negative 7. And I have to solve this equation that would have come from chapter 2. I need to solve for x, which means I'm going to add 4 to both sides. 3x is equal to, what do I get with a negative 7 and a positive 4? Negative 3. Final step, divide by 3. X is negative 1.
So whenever you go to solve for y, you pick one of the equations, and then you take, like,
What you already found and plug it in, so then you're looking for the other variable.
oh, okay.
Okay,
So
so
you're really just working on that bottom one. That
Yes.
top one's just a copy of it.
yes, yeah. I always just copy it down.
So that's basically it, you just put y equals and x equals, and you don't have to put it like in any form?
Well, in this particular lesson, if I go all the way back up to the question, it says the solution is, in this lesson, you're still doing ordered pairs. But when we get to 4, 5, we won't do ordered pairs anymore. So for this one, the answer is negative 1, just like that. Okay? Let's look at number 3. Number 3 says, solve the system of equations by the addition method, and I'll copy it down. I have 2x plus 6y is 2, and I have 6x minus 6y is negative 18. Okay, does everybody see that you do have opposites, and they are in the y's? Then I'm going to pause the recording, and I would like y'all to solve this system. Boom. All right, when I choose to add these together, I add the x terms for 8x, the y's cancel, I add the constants, which means I really end up subtracting, keeping the sign of the dominant, I get negative 16. I divide both sides by 8, and I get x is negative 2. So that's the first half of my answer. Now, what letter am I going to have to solve for? All right, now find y. You get to, and if if it's frustrating you deciding which one to pick, well then just always pick the first one. That's not necessarily great advice because it might not be the easiest way, but it will work every time. So if I pick 2x plus 6y equals 2, and I plug in the value for x, I'm going to have 2 times negative 2 plus 6y is 2, negative 4 plus 6y is 2, add 4 to both sides, that gives me 6y is 6, divide by 6, and y is 1. It will want an ordered pair, so your ordered pair should be negative 2 and 1. You want to make sure that whatever value you get for x, that you carry it carefully into that location. Is everybody okay? Did you get it right? And if you didn't get it right, did you find out where you went wrong? Okay, let's look at number 4. This is the first problem where it's not ready for substitution. So let me copy it darker. I have 3x plus 2y equals 0, and I have 9x plus 6y equals 1. All right, looking at the system, I notice that the x's are lined up, the y's are lined up, the equal signs are lined up, and the constants are lined up, so the structure's okay. The next thing is I look at the x's. Are those opposites?
No.
I look at the y's. Are those opposites? No. I have to now do some manipulation to cause these to become opposites. Okay? Now, what I'm going to use is some multiplication. Do you remember when we had a fraction in an equation that we were allowed to multiply all the terms by the LCD if we wanted to? You can multiply all terms of an equation by a number, and you get a new equation, which is still true. Okay, you've already got the number, but let's clue everybody else in. All right, what you're looking for is very much like the same process you would do if you were finding a common denominator, a least common denominator. These aren't denominators, though, so I'm not going to call it an LCD. I'm going to call it a least common multiple, but it's the same process as common denominators. If you had a denominator of a 3 and a denominator of a 9, what will 3 and 9 both go into? No, not what will go into them. What will they go into? 9. Because 3 goes into 9 and 9 goes into 9. It would be the common denominator. All right, the least common I'm going to put LCM is 9. I'm just going to write that little note on there. What would you have to multiply 3 by to turn it into 9? 3. What would you have to multiply 9 by to turn it into 9? 1. In other words, you wouldn't need to change it. But do you agree that turning them both into positive 9s is not exactly what you want? One of them has to go negative? Okay, so I'll have to account for that. But let's have more discussion. Let's look at the y's. Forget about the x's for a minute. Look at the y's. What's the least common multiple for 2 and 6? What will 2 and 6 both go into? 6. The LCM is 6. Now, I don't always write that down. I'm just doing it because it's the first time we've done this kind of problem. What would you have to multiply 2 by to turn it into 6?
3.
And what would you have to multiply 6 by? 1, or not change it. Okay, it sounded like whether we were working with the x's or we were working with the y's didn't make much difference. It seemed like we had to do the same thing. That's very much just particular to this problem. Usually you have to do different things, but you'll see that in other problems. So, if y'all don't mind, I'll go ahead and take charge of the question, and I'm just going to tell you, not because it's a lot easier, it doesn't make much difference, that I'm going to target the x's. I'm going to make it happen with the x's. It makes no difference. All right, you told me that if I want these both to be 9s, that I have to take the first equation, and you'll see me draw this little arrow when I'm going to change something. I did the same thing with substitution. And I'm going to multiply it by, what did you tell me I needed to multiply it by? 3. But if you don't mind, I'm going to make that be a negative 3. Because what's that going to turn this coefficient into? A negative 9. And would that then be the opposite of this one?
Yes.
That's my goal. I have to make a pair of opposites. I can do this as long as I multiply it times 3x, 2y, and 0. You have to multiply all the terms of the equation. So here I go. Negative 3 times 3x gives me negative 9x. Negative 3 times 2y gives me negative 6y. Write down your equal sign. Negative 3 times 0 leaves me with a 0. Sometimes if you just looked at this, you might think I didn't multiply the right-hand side, but I did. I just still got a 0. Am I making any changes to the second equation? No, so I'll just copy it down. 9x plus 6y equals 1. So let me pause for just a minute. All I've done so far is work on getting it ready for addition. I have to have a pair of opposites. I do that by multiplication of some number that will give me the least common multiple in one of the two columns. Now, something unique happened in this problem. I was working real hard focused on these x's, and I ended up with them on both. Well, what in the world does that mean? It's time to add. If I add, my x's are opposites. And coincidentally, my y's are opposites. Now, I can't just avoid the left-hand side. What am I going to write down? 0. I have to write down something. Equal sign, and 0 plus 1 is 1. Do you recognize that we just moved to one of those weird systems? And when I say weird, that's not very mathematical. What I'm saying is it's one of the either no solution or infinite solution categories. Because this is a false statement, it is no solution. When you're in one of those weird categories of no solution or infinite solutions, the problems are resolved very quickly. You drop out all your variables, you simply look at the leftover statement. If it's false, the answer is no solution. What would the statement look like an example of if it were supposed to be infinite? The same. 0 equals 0. 1 equals 1. 9 equals 9. I will tell you in addition it's going to be 0 equals 0. But if it's true, it's infinite solutions. If it's false, it's no solution. Of the scenarios, do I have intersecting lines, parallel lines, or coincidental lines? I have parallel lines because there is no intersection. They share nothing. There's no point that is a solution to both of them. Okay? Let's look at 5. Number 5 is negative 2x is equal to 5y plus 10, and negative 4x minus 7y is equal to 8. My x's line up, and then I say, oops. I have an equal sign sitting over the subtractions. They're not lined up. Before I make any other decisions, these aren't in the right format, or at least this guy isn't. I like them to be x's, y's, equal signs, constants. So let's take a minute and let's fix that one. I have negative 2x is equal to 5y plus 10. What will I need to do to make it be in the right format?
Add 5y to it.
Okay, I do need to get the 5y from the right-hand side to the left-hand side. And I was waiting for you to look at it a little more carefully and see that I needed to subtract 5y. That would leave me, those are not like terms, so I'll just line them up. Negative 2x minus 5y, gone, equal sign 10. Many of you are at the stage where you could have looked at this original problem and said, oh yeah, I just need to move the 5y over here and it'll become negative. All right, so I'm going to rewrite the system. You don't necessarily have to rewrite it as many times as I do. Whoops, sorry. Okay, in this, you mean move this one instead? Well, actually, some people can mentally make enough changes that it feels like you're just moving an equal sign, but there's no real algebra rule that allows that. It is terms that can move from one side to the other, and it appears as if the equal sign might have moved, but when a term moves, its sign changes. So you wouldn't want to just pick up an equal sign and push it over here, because the 5y has to become negative 5y. So be real careful, don't just move an equal sign. Okay, I'm taking an extra step to do this. I now have negative 2x minus 5y is equal to 10, and negative 4x minus 7y is 8. Pardon? It's still not ready. Okay, so we've already done a bunch of work, and it's still not ready. I know, it happens sometimes. All right, x's, they are not opposites. Y's, they are not opposites. Let's discuss each one of them. the x's. What's the least common multiple? What will 2 and 4 both go into? 4. The least common multiple is 4. And I'm not worried about the signs yet. I'll take care of that in a few minutes. What would I have to multiply -2 by or 2 by to get 4?
2,
A 2. What would I have to do to the second one?
1.
A 1 or no change at all. So all I'd have to do is change the top equation, and I'd worry about signs, but that's all I'd have to do. Look at the y's, because I'm trying to look at it and evaluate which way should I go. Y's, what's the least common multiple for those two numbers? 35. What would I have to multiply 5 by to get 35? 7. And 7 by? 5. If I do the y's, I'm going to have to change both equations. If I do the x's, I only have to change the top one. And I like to do the least amount of work I can get away with. So I'm gonna work on the top one. I need this -2 to become a 4. So I'm going to multiply by 2. What about signs?
You're going to be a
No,
power.
you're gonna, negative 2.
It should be a -2. And here's the reason. This one down here in the second equation is already negative. So I need this to become positive. That is usually the smaller of your issues. Okay.
Wait, so then why do you have a -2?
Okay, because this one down here was -4. So in order to make this become its opposite, it needs to become +4. And it's going to take negative times negative to get a positive. Okay? So what do I get? I have -2 times -2x is positive 4x. I have -2 times -5y gives me positive 10y, equal sign. I have -2 times 10 is -20. I am not changing the second equation. That's -4x minus 7y is equal to 8.
Are there gonna be problems where you have to change those?
Yes. but you'll see, I promise, I'll demonstrate it. All right, now it's time to do what the method says, which is add. The x's cancel. I end up with 3y because I have positive 10 and -7. I have -20 and positive 8, which is -12. Divide both sides by 3. And y is -4. Okay. So I've done a couple of steps so far. First thing, I didn't have my like terms lined up, so I took a minute to do that. Then I looked at my new system and said, oh, it's not ready. I've got to make sure I've got opposites in either the x's or the y's. It was a smaller task to get those x coefficients to be opposites. All I had to do was multiply the top equation by -2. Once I did, I added, got a pretty easy equation to solve, divided by 3, and I have a value for y. What will I do next? Now, find, I've got y, so it must be x. I'm going back up to show what's on the screen. You have, if you'll look at the screen with me, you have one equation here, you have a second one here, but you have a third one here and a fourth one here. Now, number 2 and number 4 are the same. Nevertheless, there are 4 equations written on the screen. You may pick whichever one you want to solve for x. Out of the 4. Any one you want. As a matter of fact, you could even go over here and pick one of these. If it's an equation with x and y, you can pick it. It's your choice. Look at all the equations up here and don't get yourself stressed out about it. Just pick one. Pardon?
You pick it.
I'll pick it. Okay, you gave me the job. Okay, you can pick, literally, and I'm going to point to them. You can pick this one, this one, this one, this one, or this one, or this one. They're all equations involving x and y. I tend to stay away from these because lots of times the numbers are bigger. If you are stressed about what I pick the first one. Just make yourself a rule. If you don't want the decision, pick the first one. And if you see something looks easier, pick it. So I picked negative 2x equals 5y plus 10. Why did I pick it? I did not have a real good reason. I picked it because it was first. Okay? And I'm going to plug in the value of y. So negative 2x is equal to 5 times negative 4 plus 10. Negative 2x is equal to negative 20 plus 10. Negative 2x is equal to, what's negative 20 plus 10? Negative 10. Divide by negative 2. X is positive 5. Remember, this equation right here is your choice. It's your choice. And yes, the answer is 5, negative 4. It is 5, negative 4. All right, let's look at number 6. Number 6 says we have 4x plus 2y is 2, and 3x minus 3y is negative 30. This is my system. The structure of the system is okay. X's are lined up, Y's are lined up, equal signs, and constants. So that's okay. I look at my X's. Those are not opposites. My Y's are not opposites either. Even though they have different signs, they're not opposites. What's the least common multiple for 4 and 3? What would I have to multiply 4 by?
3.
And what would I have to multiply 3 by?
4.
Okay, and one of them would have to be negative to get opposites. All right, look here. What's the least common multiple?
6.
6. What would I have to multiply 2 by?
3.
And 3 by?
2.
2. But those already have different signs. So you tell me it's decision time. And there's not a right or wrong answer here. Do you want to work on the X's or the Y's? The Y's. I'm going to work on the Y's. I think it is the more efficient path. All right, now, and you asked Sarah, am I ever going to have to change both of them? And the answer is yes, and we're about to do it. If I want to make both of these Y's become 6's, what am I going to have to multiply 2 by?
3.
3. So I'll do that in just a minute. What am I going to have to multiply the 3 by to turn it into 6?
2.
And are the signs okay? Yes, because I've already got 1 plus and 1 minus. Now, distribute this 3 to all terms. 3 times 4x is 12x. 3 times 2y is 6y. 3 times 2 is equal sign 6. Next one. 2 times 3x is 6x. 2 times negative 3y is negative 6y. Equal sign. 2 times negative 30 is negative 60. If you chose the right numbers, you have created a pair of opposites. And you can see that we have. Now, use the addition method. Add those for 18x. The y's cancel out. Positive 6 and negative 60 is negative 54. Divide by 18. and x is equal to -3. Is that much okay?
So once you find the least common multiple,
Mm-hmm.
because like whenever you did that, I would have assumed that you would multiply by the least common multiple.
Okay.
That's not the case.
That's not the case. Okay. When you get the least common multiple, that just gives you a target for what you want these numbers to turn into. So you have to decide what will I have to multiply it by to get that. Just like when you get a common denominator and you say, okay, I've got a half, what am I going to have to multiply it by to get something? Question? What did I do? I'm sorry, say again.
Why did you do both of them this time?
Both of them?
Yes.
Oh, okay. I did both of them because if I went back to a previous problem, the least common multiple here was one of the two numbers. Okay, does that make sense? Okay. And I'm not through. Now, find y. I've got to find y. We have decision time. And it seems like we don't want to make decisions in here very much. So we have 1, 2, 3, 4 to choose from. Use the first one, you bet. We now have a method. We have 4x plus 2y is 2. I have a value for x to plug in. Can't see it very well on the screen, but it's there. 4 times -3 plus 2y is equal to 2. -12 plus 2y is 2. Add 12. 2y is equal to, if you could read that blob, 14. Final step is to divide by 2. And y is 7. It's messy, but -3, 7 is my ordered pair. Yes, sir.
How do you know when to do both of them?
Okay. You will know that you have to change both equations when the least common multiple is not one of the two numbers. That means to turn them into 6, they're both going to have to change.
So let's just know you have to multiply 4 times 3, and it's not going to equal 3, it's going to equal like 12.
Well, the least common multiple, I mean, one thing you can do if you want to is you can always use the product of the two numbers and you'll always have to multiply both of them. But it's like getting a common denominator. If I back up to this previous problem to show it, here I can use 4 as the least common multiple, so I didn't have to change both of them. I only had to change that one. Same thing happened in problem number 4. I could use 9 as the least common multiple, so I didn't have to change both of them. But on number 6, 4 and 3, you can't use one of the two numbers that's there. They both have to change. Same thing with 2 and 3. Okay, last one. All right, it is 2x minus 6y is equal to 10, and 3x minus 9y is equal to 15. We've got that same least common multiple issue to deal with again. All right, what's the least common multiple for 2 and 3? Okay, LCM is 6. Neither of those is a 6, which means it's going to require both of them to change. What's the least common multiple for 6 and 9? 18. Neither one of those is 18. That means they both have to change. Do you want me to work on turning these x coefficients into 6s or the y coefficients into 18s? 6s. I usually go with smaller numbers. So I choose to work right there. Now we have to figure out what the numbers will be. What do you have to multiply 2 by to get 6?
3.
What do you have to multiply 3 by to get 6?
-2. Well, 2.
2. And now, you were right, one of them's got to be negative. Do you care? No. Then I'm going to make it match the notes that get posted, and so I'm going to put the negative up there. But it is not a requirement. It could have been down here. But you have to make one of these turn into positive 6 and one of them into negative 6. Because they have to be opposites.
And if one was a negative, like say that 2 is negative,
Uh-huh.
then you would make it.
Then they'd both be positives over here because
Yeah.
you wouldn't worry about sign changes. Okay? So here we go. Positive 2x times negative 3 is negative 6x. Negative 6y times negative 3 is positive 18y. Equal sign. 10 times negative 3 is negative 30. Second equation. 2 times 3x is 6x. 2 times negative 9y is negative 18y. Equal sign. 2 times 15 is 30. Now, I was working on my x's, but what happened? They both. All right, which means we've entered into one of those weird situations. Both the x's and y's are opposite, so I get 0. What is it? Negative 30 and positive 30 is 0. So that's true, which means what's the answer? Infinite solutions. And if I were graphing it, would it be intersecting lines, parallel lines, or coincidental lines? It would be coincidental. They intersect everywhere. They have an infinite number of solutions. All right, that takes that lesson to its conclusion.